So I've presented the theory behind the sigma notation and the properties associated with it. What I'm going to do in this video here, I'm going to present you with a couple of examples. I want you to read the questions, pause the video, have a crack at them, and then come back and see how you got on. So here are your questions. First one I want you to do is evaluate a pair of sums that I've got there for you using the various properties. The second one, I want you to find the value of the unknown below, i.e. the value of n, such that that sum works out to negative 148. And then the last one, I want you to express explicitly that expansion as a function of n, using the properties of series and sequences you know. So pause the video and have a crack. So the first one, I want to evaluate, for part A, the sum from r equals 1 to 7 of 2r plus 1. Well, let's use the properties we know to split this up into much easier things to work with. Because what I can do is split that into 2 times the sum from r equals 1 to 7 of r, plus the sum from r equals 1 to 7 of 1. Now, I know that the sum from r equals 1 to n of 1 is just given by n. So in this case, that is going to be given by n, which is the top value, so 7. The sum from r equals 1 to n of r, I know that that's a half n bracket n plus 1. So in this case, that's going to be a half times n, which is 7, times 7 plus 1. But I'm also multiplying the whole thing by 2. So I've got 2 times that. Now 2 times a half, they cancel. 7 plus 1 is 8. I've got 7 eighths. So I know that that's then 56. But I've got to remember I'm adding on 7 there as well. 56 plus 7 is 63. So there you go. Answer to the first question there. Second question is the sum from r equals 4 to 5 of 3 minus r. Now again, we can use the properties we know to split that up. So I can say fine, so it's the sum, so it's 3 times the sum from r equals 4 to 5 of 1, take away the sum from r equals 4 to 5 of r. Now here's the issue, we don't start at 1, we start at 4 for these. Now what we have to remember is that we can split the sum from r equals 1 to n off into the sum from r equals 1 to a plus the sum from r equals a plus 1 to n. So we can split it off into 2 different sums like that. And I can then equate this and shift it around to say, therefore, the sum from r equals a plus 1 to n is equal to the sum from r equals 1 to n, take away the sum from r equals 1 to a. So I can use this format for these ones because if r equals 4 to 5, that means a plus 1 is 4, n is 5. So to do this one, I'd have to do 3 times the sum from r equals 1 to 5 of 1, take away the sum from r equals 1 to 4 of 1. And in this case, that's going to give me 3 times 5 minus 4. 5 minus 4 is 1, so that just gives me 3. So that first term simplifies to that. Use the same logic for this second term here. So the sum from r equals 4 to 5 of r, that's going to be given by the sum from r equals 1 to 5 of r, take away the sum from r equals 1 to 4 of r. So I remember that sum from r equals 1 to n of r is equal to a half n bracket n plus 1. So this first one here gives me a half times 5 bracket 5 plus 1. Take away the second one, which is a half times 4 times bracket 4 plus 1. So this first one here, 5 times 5 plus 1 is 30, divided by 2 and I get 15. That's then going to be take away half of 4, which is 2, 4 plus 1 is 5, 2 5s are 10. So 15 take away 10, that's going to equal 5. So I can then put it back into here, because I know I've got 3 times this sum here, which is 3, take away this answer here, so I then end up with 3 minus 5, so I get negative 2. Getting a negative answer is perfectly acceptable in these cases. We're allowed that. I mean, you could even judge that just by looking at it, because 3 minus r, well, when r hits 4, you start to get negative values. So it's going to dominate, and I could end up with a negative answer. So bear that in mind when you're working these through. Question 2 was finding the value of the unknown below, so finding the value of n. So what I'm going to do is use the same idea and split this left side up and see what I can do so I can get a value of n where I get an answer with that. So splitting it up, I get 4 times the sum from r equals 1 to n of 1. Take away 5 times the sum of r equals 1 to n of r. What that then gives me is 4 times n from that first term. Take away 5 over 2 times n bracket n plus 1. And I know that that has to equal negative 148. So I've got some sort of an equation to solve here. Well, let's start by getting rid of this 2 here and multiplying out this bracket. So if I multiply everything by 2 to get rid of that, I get 8n, and then take away 5n squared as I multiply out the bracket, minus 5n equals negative 148 times 2, because remember we're multiplying every single term by it, so negative 296. Well, I've got an n squared here, so I've got a quadratic. So I can put that in a quadratic form, i.e. the quadratic equal to 0, and solve it, and then I can get my answer from that. So if I rearrange it, I get 5n squared minus 3n minus 296 equal to 0. So to solve it, I'd factorise this, I'd get my 2 solutions, and I'd see what I get from that. Now, you'd look at that and think, well, I'm going to get 2 solutions, so I get 2 values. Well, the fact that I've got a negative here means I've got 2 numbers multiplying to give me a negative. So I'm going to get 1 positive answer, 1 negative answer. So I'm going to get 1 solution from that. If I were to factorise this, so if I take it and factorise the whole thing together, what I'd end up with is 5n plus 37 in one bracket, and I get n minus 8 in the other. So if I solve these two, I get n equals negative 37 over 5. And I get n equals 8. Well, it's pretty elementary in this one. I know it's a negative one here. I can't have a negative number of terms. That goes, and I can focus on that. So for this to work, I know that n has to equal 8. That's the solution I want, and that's the solution I'm going to take. Last one was expressing this explicitly as a function of n. Now, whenever you get a question like this, what you want to do is write it out as a sum of terms involving sums. Now, that makes sense because what you do is if you can write it like that, we can use the properties we know of sums given the sigma notation such that we can then put them all in and solve it and write it out from there. So the first thing I'm going to do though is multiply out this bracket. So if I take this bracket and multiply the whole thing out, I get r squared plus 2r plus 1 minus r squared. So what I can do is rewrite this as the sum from r equals 1 to n. The r squared will go of 2r plus 1. Now that's a heck of a lot simpler than this. And at this stage, we split it up using our properties and see what we get. So if I split this all up, I know it's going to be 2 times the sum from r equals 1 to n of r plus the sum from r equals 1 to n of 1. This first term here, what that gives me is 2 times a half n bracket n plus 1 plus the second term, which just gives me an n. When you get one like this, multiply all the brackets out at this stage, gather it all together, and then simplify it from that. So 2 times a half cancels, then multiply out the bracket, and I get n squared plus n plus n. So in this case, I get n squared plus 2n. We could factorise the n out, and I have n bracket n plus 2. This one might be easier because if I told you, for example, n was 3, I know it would be 3 times 3 plus 2, so 3 5s, 15. But either version is fine unless it asks for a specific format. Bear that in mind. If it wants a specific form, you have to put it in that form. These are the kind of questions we need to remember these rules for. They come in handy when we're working with stuff later on, but this is the basic idea and the basic premise that we have to work with so that we can answer these types of questions.